Hi everyone, this is Professor Oaks, and in this video we are going to talk about some applications of systems of equations. So let's start with the first one here. The sum of Sean's and Maria's ages is 75. So I'm going to write that down right now. So Sean's age, and sum means add, so plus Maria's age is equal to 75. Maria is 15 years older than Sean. So Maria's age is equal to Sean's age plus 15 more years old. And they want Maria's age because they say, how old is Maria? So Maria's age is what we need to figure out. So instead of Maria's age and Sean's age over and over again, I'm just going to use S for Sean and M for Maria. So S plus M is 75, and M is equal to S plus 15. Well, then I can see that a good way to solve this system of equation might be to substitute this into this equation, all right? So we have S plus 15 is equal to 75. Then combine like terms. So again, we use the substitution method here. So 2s plus 15 is equal to 75. Subtract the 15 to get 2s is equal to 60. Then divide by 2 to get s is equal to 30. So that means Sean's age was 30, but they asked for Maria's age. So Maria's age would be Sean's age plus 15. So 30 plus 15 means that Maria is 45 years old. So Maria is old. All right. Actually, I don't think 45 is that old, so I shouldn't be too hard on her, right? All right, so now let's do another example here involving age. All right, so the sum of Emily's and Andrew's age is 48. So Emily's age plus Andrew's age is 48. Then 12 years ago, Emily was 3 times as old as Andrew. So that means that, all right, so Emily's age. Now, remember, this was 12 years ago. All right, so 12 years ago, Emily was 3 times Andrew's age. So how are you going to take that 12 years ago into account? Well, what you actually do is remember that this is Emily's age now and this is Andrew's age now. So 12 years ago would be Emily's age now minus 12. All right, and then 12 years ago would be Andrew's age now minus 12. All right, so now I could just use E for Emily's age now and A for Andrew's age now. So E plus A would be 48. Then E minus 12 is 3 times A minus 12. All right, remember one thing that really is important is to make sure that you put the parentheses around what Andrew's age was right, 12 years ago, because I'm writing it as a minus 12. All right, so now let's go ahead and distribute the 3 here. So e minus 12 is 3a minus 36. Then I can get the equations both written in the a, x plus b, y equals c, or in this case, it would be just to line up the e's and the a's above each other. All right, so general form, just to see what's going on, all right? So let's add the 12 to each side. So e is equal to 3a minus 24. Now, then you could subtract the 3a, so e minus 3a is equal to negative 24. So here is one equation, and here is the other equation. So I'll write them next to each other. E plus a is equal to 48, and e minus 3a is equal to negative 24. Now, let's go ahead and figure out if we can eliminate one of these variables. And remember, we want Andrew's age now, or how old is Andrew now. So we need to really eliminate Emily's age now from the equation. So I can do that by multiplying by negative 1, negative 1, negative 1 to eliminate the e's. So e plus a is 48, and negative e plus 3a equals 24. Then the e's are eliminated, so I have 4a is 72, and when I divide by 4 on each side, I get Andrew's age now is 18. So Andrew is 18 years old right now. What a time to be alive for Andrew. All right, so now let's look at another example here. So we did a couple of age problems. So let's do a money problem now. Excuse me. So you have a jar containing 91 coins consisting entirely of pennies and dimes. So here it is. So the number of pennies plus the number of dimes has to equal 91 coins total of either type, pennies or dimes. And the total is worth $4.06. So whenever I am doing money problems, I'm going to have one equation for the number of coins and the other equation for the amount of money that I have. All right, well, I know that pennies are worth 1 cent, so 1 cent times the number of pennies will tell me how much I have in pennies, plus dimes are worth 10 cents, so 10 cents times the number of dimes will tell me how much I have in dimes. So if I let P be the number of pennies and D be the number of dimes, I could write the system of P plus D is 91, and 0.01P plus 0.10D is 4.06. And I want how many pennies are in the jar. So I want to know the number of pennies in the jar. All right, now a lot of people don't like working with the decimals, right? So one way to eliminate the decimal would be to multiply by 100 to clear out the decimal here. Or you could just go for it and see what happens. But let's just go for it. All right. So now, if we need to eliminate the number of dimes in the equation to solve for the number of pennies, I look here and I can see that if I multiply by negative 0.10, negative 0.10, and negative 0.10, I have negative 0.10p minus 0.10d, and then I have negative, let's see, I just want to make sure what I get when I add it to the 4.06 will be what I think it is. All right, good. So negative 9.1 or 0, just to make sure that we line up the decimal places together, will be 0.01p plus 0.10d is 4.06. All right, so now the d's are eliminated. Negative 0.10 plus 0.10 is 0. Then we have a 0.09 negative p is equal to negative 5.04. And then I can divide by negative 0.09 to get p is equal to, and this will be, let's see, what will it be here? 56. So there are 56 pennies in this jar of coins. Now, if we wanted to find the number of dimes, could we do that? Yes, because we knew that the total was 91. So P plus D was 91, and we know the number of pennies was 56. So I subtract the 56 from the 91 to get that there were actually 35 dimes in the jar. What a time to be alive. We did all of this work for $4.06. All right, so let's do another problem. So that was a money problem. So let's try an example here of a total of 15. Is it 15? Oh, no, there it is. 516 tickets were sold to a concert. So number of tickets sold, there were 516, and the total dollar amount sold, you can see, was 5,507. All right, so two types of tickets were sold. Adult tickets were sold for $15 each, and child tickets were sold for $8 each. How many adult tickets were sold? So I know that the number of adult tickets sold plus the number of child tickets sold is equal to 516 tickets sold in total. All right, and I also know that the adult tickets were $15 each. So the number of adult tickets sold at $15 each plus the number of child tickets sold at $8 each will give me the $5,507, the total sales, or the total amount sold. And the question asked for the number of adult tickets sold. All right, so how many adult tickets were sold? All right, so now let's go ahead and try this problem here. So I'll use A for adult and C for child. So A plus C is 516. And then this is similar to the coin problem. So 15A plus, let's see, did I say this? Yes, I said $8 each. So 8C is equal to $5,507. All right. So if I want to solve for the number of adult tickets, I need to eliminate the number of child tickets from here. So I can multiply by -8 to do this. So we have -8A minus 8C, and then this will be, let's do this mentally here. So -4,128. Then I have 15A plus 8C is 5,507. Then I'll do the elimination step. So 8C minus 8C, 0. So we have, let's see, what do we have here? We have 8 minus 15 is 7, so 7A, and -4,128 plus 5,507 will be 1,379, and then I divide by 7 on each side to get A is 197. So I see that the number of adult tickets sold was 197. Now, if they asked me for the number of child tickets sold, instead, I could find that out easily because A plus C was 516. I can substitute the 197 and then subtract the 197 from 516 to get that there were 319 child tickets sold. What a time to be alive. I don't know how many people do this on their everyday basis, but I think that it's definitely something fun to do, right? Let's try another example here. A plane takes off at 9 a.m. All right, so traveling south at 250 miles per hour. So here is the plane, and he's going south. All right, so south at, so here's the plane, south at 250 miles per hour, and he leaves at 9 a.m. All right, and the jet, he takes off at 10 a.m. and he goes south at 480 miles per hour. All right, so how are you going to write this so that you figure out at what time will the jet overtake the plane? All right, so I know that the distance of the plane is actually equal to, all right, now remember the formula, distance equals rate times time, right? So the distance of the plane is equal to 250 miles per hour times how far he gets. All right, and then the distance of the jet will be 480 miles per hour, but this will be, all right, so this is the time. All right, then this will be the time minus 1 hour because the jet left an hour later than the plane, so we have 1 hour less time. All right, so now when will the jet overtake the plane? Well, that means I need to figure out when these two distances are equal, and then that's the point at which the jet will then go past where the plane is at. So let's set these equal to each other. So 250 times t, let's just say for time, is equal to 480 times t for time minus 1. Then distribute the 480, so 250t is 480t minus 480. Then I will subtract the 480 to get negative 230t is negative 480. Then I'll go ahead and divide by 230. So t is 480 over 230, or t is 48 over 23, and that is 2 and 2/23 of an hour. Now, I need to figure out what that is in minutes. All right, so now I have 2 hours, and then I'm going to take the 2/23 of an hour, and I am going to actually multiply by, all right, 60 minutes in 1 hour, so that the hours will cancel out here and just give me the number of minutes. So then I have, what will that be? 120 over 23. So 120 over 23 will be 5 and 5/23 minutes. So 2 hours and 5/23 minutes. So I know if the plane started at 9 a.m., then that's approximately 2 hours and 5 minutes, all right, to the nearest minute. That if I add that time on plus 2 hours, 5 minutes, that the jet will overtake the plane at approximately 11:05 a.m. So 2 hours and 5 minutes later. What a time to be alive. I hope that you really enjoyed this example here. So let's try another example. A solar heating system cost $15,250 to install with a yearly operating cost of $150. So here is the solar heating system. There is a $15,250 installation cost, and then there are $150 of yearly operating cost, and then we have the electric heating system, and that cost $4,000 to install, but it has a $750 yearly operating cost. So they want to know then how many years will pass before the total cost of the solar heating system is less than the total cost of the electric heating system. So the solar heating system, S, is $15,250 plus 150 Y for the number of years, like how much it cost per year, all right? And the electric heating system is $4,000 to install plus $750 per year. All right, now it says, how many years will pass before the total cost of the, so this is the the total cost. All right. And that's the total cost, just so that you know that that's what I mean. And then y, again, is the number of years. So the total cost after a certain number of years, all right? So how many years will pass before the total cost of the solar heating system will be less than the total cost of the electric heating system? All right, so I know the solar heating system was 15,250 plus 150y, and the electric heating system was 4,000 plus 750y, so I need to just solve this for y. So let's subtract the 15,250 on each side. So 150y is less than 4,000 minus 15,250 will be negative 11,250 plus 750y. We'll subtract the 750y on each side. So 150 minus 750, that will be negative 600y is less than negative 11,250. Then divide by negative 600. So then I'm dividing by negative, so I need to switch the sign. So if I do that, I get it is greater than 18.7. So if I round to the nearest year here, I am going to say that it will be 19 years. What a time to be alive. So at this rate, it would take 19 years for the solar heating system to pay off. So you're planning to live somewhere for that long, then go for it. You might actually save some money in the long run if you don't actually start sweating too much from your house being heated from all that extra sun. All right, let's try another example here. What a time to be alive. All right, so let's see. Yep, here we go. A salesperson applying for work is considering two job offers. Company A offers to pay $125 plus 10% of sales per the day. All right, sales total for the day. And Company B offers $75 per day plus 15% of total daily sales, or 15% of sales total per the day. So what are the smallest daily sales that will make Company B as lucrative for the salesperson as Company A? All right, so Company A is 125 plus 0.10 times the total sale for the day. So I'm going to abbreviate here. So Company B is offering $75 plus 0.15, 15% of the total sales per the day. So let's see when these are equal to each other. So 125 plus 0.110t is equal to 75 plus 0.15t. We'll subtract the 75 on each side, so 50 plus 0.10t is 0.15t. Let's subtract the 0.110 or 0.10 or 0.10t on each side. So 50 is equal to 0.05t, and then I'll divide by 0.05 on each side. So if I do that, I get that t is equal to 1,000. So $1,000 is the smallest daily sales that the person would need to make in order to make company B as lucrative for the salesperson as company A, meaning that the person would make just as much money at company B as at company A if the person made $1,000. All right, so let's try another wonderful example. I hope that you're enjoying these so far. So here's an example. Calculate how much 30% salt solution, so 30% salt solution and 70% salt solution must be mixed. So that's to end up with exactly 9 liters of a 60% salt solution. All right, so the 30% salt solution plus the 60% salt solution has to give you something that's a mixture of 30 plus 70. I said 70. Has to give you a mixture that is a 60% salt solution, and you want 9 liters of it. All right, so let's look at this. You don't know anything except that one of these needs to be 30%, one 70%, and the mixture needs to be 60%, and that there are 9 liters total. All right, so let's say that there were X liters of the 30% salt solution, and that there were, say, Y liters of the 70% salt solution. So X plus Y is 9. Then I know that this is very similar to the other problems that we've had here, but I can make this 0.30. X will tell me the amount of salt in this X liters here, plus 0.70 Y will tell me the amount of salt in the Y liters here, and then the 0.60 times 9 will tell me the amount of salt in the 9 liters. So in other words, what I have is X plus Y is 9, and 0.30X plus 0.70Y will be 0.6 times 9, so that's 5.4. And they want me to answer the number of liters in the 70% solution. So that means I need to find out what Y is equal to. So that means I need to eliminate the X. So I can eliminate X by multiplying by negative 0.30, negative 0.30, negative 0.30. So we have negative 0.30x minus 0.30y, and then 0.30 times 9 is 2.7. So 0.30x plus 0.70y is 5.4. The x's zero out now. So negative 0.3 plus 0.7 will be 0.4. So 0.4y and 2.7 plus 5.4 is going to be, let's see, what will that be? When I divide by 0.4, well, in either case, I have, what do I have here? I have